All right, calculus students, here we are investigating the indefinite integral and the difference between an indefinite and a definite integral, if I can show you here for a second. That is what we call a definite integral, and it's definite because it has bounds. Meaning that if you looked at that graphically, you would say, well, that's x squared, and we're going to bound it from 0 to 3. So we're going to look at that area. So we're actually calculating area underneath the curve. That's what we have. Whereas in this situation, the integral, that's what that line means, integral, x squared dx, that's the indefinite integral. Indefinite because there are no bounds. And here's the key when you have an indefinite integral. The indefinite integral, if you determine this, will be x cubed over 3. Or x cubed over 3 plus 2. Or x cubed over 3 minus 18. Why? Because when you take the derivative, you get x squared. And when you take the derivative here, notice that you get x squared, and then the derivative of 2 is 0. And when you take the derivative of this, you get x squared, and the derivative of negative 18 is 0. So there's an infinite number of antiderivatives. And so when you have an indefinite integral, what we do is to show that we can have any constant on the end there is we write this. The indefinite integral, the integral of f of x dx is equal to the antiderivative plus c, where c is any constant value. The definite integral, as we said, the integral a to b of f of x dx, that is in fact big F of b minus big F of a. So we get a numerical result in that situation. That's the difference between definite and indefinite. In this unit, we're going to spend considerable amount of time on both, but our focus turns to the indefinite integral. So it says verify by differentiation that the formula is correct. Or in other words, anytime you come up with an indefinite integral, an answer, you can check to make sure your answer is correct by taking the derivative of what I've underlined, and you should get that. So an easy example, the integral of 5x dx, we would say is 5x squared over 2 plus c. Well, if you want to show that's correct, take that derivative. If you put the 2 in front, notice you get 5x, and the derivative of c is 0. So that matches up with that. So you can always take the derivative to check to see that they work. So let's show that in this situation. So this is a reminder of some of your integral derivative type problems. I want to take the derivative of that expression. X cosine of x minus sine of x plus c. I'm going to take that derivative. Notice that the part that I underline here requires the use of the product rule. And the derivative of x is 1 times cosine of x plus x times the derivative of cosine is negative sine of x. And then the derivative of negative sine is negative cosine of x. And the derivative of c, it's a constant, is 0. Notice that this will combine with this, and they will, in fact, cancel. And in this situation, you end up with negative x sine of x. This is the same as that. So therefore, you verified that that is correct. We're going to try another one. This one looks a little complex. I thought about taking it off, but I know that you guys are rather intelligent. So we're going to take the derivative of this guy. I'm going to rewrite it as 2 over 3a times ax plus b raised to the 3/2 power. So that's what the square root is. And then you see a cube, so 3/2 power plus c. So I'm going to take the derivative of that, and we're going to use the chain rule. And the chain rule here, we have 2 over 3a times u to the 3/2 power. And then u is ax plus b. the derivative of ax plus b is a, and the derivative of 2 over 3a, the 3 halves in front will cancel with the 2/3. So I have 1 over a, and I'll have u to the 1/2. As I multiply those together, you can see that the a and the 1 over a will cancel, and I have u to the 1/2. What is u? It is ax plus b raised to the 1/2 power, or the square root of ax plus b. Hopefully that's what I have to start with, and I sure do. So there we have it. In these directions, it says now to find the general indefinite integral. Or in short, find an antiderivative. I add 1 to -3/7, so I add 7/7, and I get 4/7 divided by 4 over 7, or multiplied by 7 over 4. Always remember to add plus c, so this simplifies to 7 over 4 times x to the 4 over 7 plus a constant. You must write plus a constant when you have an indefinite integral. I'm going to need to distribute first in this situation. Integral 2x minus 6x squared plus 2x to the 6th dx. The antiderivative of 2x is x squared. The antiderivative of negative 6x squared is negative 2x cubed plus 2x to the 7th divided by 7 and plus c. If you want to check it, take the derivative. In order to find antiderivatives from time to time, part of what you need to do is distribute. So we have 2 plus g minus 3g squared dg. The antiderivative of 2 is 2g. Antiderivative of g is g squared over 2 minus g cubed plus a constant. The antiderivative of 2 sine would be negative 2 cosine of theta. The antiderivative of 4 cosine is 4 sine of theta plus c. So I've shown you how to calculate the antiderivatives of sine and cosine, positive or negative. For those of you who may struggle with that from time to time, I put this sheet on the back here. It covers many of the important parts of calculus that we have done. Unfortunately, we left this off this year, and we also left this off this year. They're two of my favorite things to do, but something had to go, and those went. Notice on this side, you have all these derivatives. Those are all your formulas for derivatives that you've learned. And then over on this side, you now have indefinite integrals. So, you know the antiderivative of sine is negative cosine. That would mean the antiderivative of negative sine would be positive cosine. And the antiderivative of cosine is sine, so the antiderivative of negative cosine is negative sine. So I have a list there for you, things that you can keep track of. You don't know what all these formulas mean yet. You're good to go here and here and here. You also know this one, this one, this one. But the logarithmic ones we really haven't looked yet, and we will at a certain time. You don't know this guy yet at all, and we'll deal with those later. But you do know a lot of them. You also have some very useful trig substitutions, and we're going to make use of some of those in a little bit. So we go back to our page here, and notice this next one. It says integral of 3 over sine squared minus 1. Sometimes you can come up with very, very useful formulas. So, all right, in this example, we don't know how to find this antiderivative, but fortunately, given that sheet that we looked at earlier, which is some useful substitutions, I particularly want to draw your attention to one that you all must know, which is sine squared plus cosine squared is 1. And so if we take that into consideration here, you know that sine squared of theta plus cosine squared of theta is equal to 1. And you therefore know that cosine squared of theta is equal to 1 minus sine squared of theta. And you know, we've talked about all these before in previous year. So 1 minus sine squared, so therefore if you multiply through by a negative, you get negative cosine squared of theta is equal to sine squared of theta minus 1. So we know that this bottom piece here is actually negative cosine squared. So we're going to make that substitution. 3 over negative cosine squared. Well, 3 over cosine is the same as secant. I'm sorry, 1 over cosine is the same as secant. So we now have the integral of negative 3 secant squared of x dx. And so now it's in a form that we can deal with, because you do know that the antiderivative of secant squared is in fact, hopefully you have that memorized, but if you look over here, we have in fact tangent. So I go back to my problem here, we'll mix this in, and we have, this is equal to tangent of x times negative 3 plus c. And the next one, notice that we have a double angle here. Don't be quick to divide that and get tangent, because that's a double angle. That doesn't work out. You probably don't remember this, but just one point to the chart here, and this is one you can use. This is a nice, useful formula. The double angle turns to a single angle. We can do 2 sine of u, cosine of u. So see how nicely this works out. So this is equal to you know, the integral of 3 sine of x, sorry about that, 3 times 2 sine of x cosine of x over cosine of x dx. So that's our substitution. So sine of 2x is substituted to be that guy. Notice how the cosine of x is canceled. We get the integral of 6 sine of x dx, and you know that that is negative 6 cosine of x plus a constant. There you have it. So, yeah. The other piece of review we can do is we can, you know, continue to look at our definite integrals. So in this situation here, this is a little bit challenging of a definite integral to deal with. I'm going to go ahead and show you one way to deal with this. We got the integral of 1 to 2, and I'm going to raise 1 over x to the 1/2 minus x to the 1/3 over x to the 1/2 dx. So I'm just rewriting it at this point. And so that's x to the negative 1/2 minus, and then 1/3 minus 1/2 is going to be negative 1/6. So again, if you subtract those 1/3 minus 1/2, so you got 2 over 6 minus 3 over 6. Notice you get negative 1 over 6 dx. Well, now finding the antiderivative is no big deal. So it's x to the 1/2 and then divided by 1/2, otherwise multiplied by 2, minus, and then it's x to the 5/6 divided by 5/6, otherwise multiplied by 6 over 5. And in this situation, we're not going to really get a good value here. You could just go ahead and plug those into your calculator and see what you get. So we're going to quit that. And so I have 2 times 2 raised to the 0.5 power, and then minus 6 over 5 times 2 raised to the parentheses 5 divided by 6 power. And when we do that, we get 0.69 minus, and if we plug in 1, that's going to be easier. We're going to get 2 minus 6 over 5. So if we just go ahead and do that, we're going to subtract parentheses 2 minus 6 over 5, and we get negative 0.1097. Now again, if you want to check your answer, you know, you can always go into y equals, and you can type that in, parentheses 1 minus, go into math, we're going to grab cubed root number 4, cubed root of x, and then we're going to divide by the root of x. And if you go second calculate, go to number 7, again, our bounds are from 1 to 2. Just see a little bit of the graph there. But so lower limit is 1 and upper limit is 2. If we go ahead and calculate that, notice, yep, there you are, negative 0.1097. Okay, another one, we've got I'm going to write it as 4y minus 3y to the negative 2 power. And so the antiderivative of 4y is 2y squared minus, and we've got 3y to the negative 1, or 3 over y, and then the negative is going to change. Evaluate negative 1 and negative 3. Plug in the negative 1, and we do get 2. Then we get minus 3, minus, plug in negative 3, and we get 9 times 2 is 18, and then a minus 1. So you have negative 1 minus 17 is negative 18. That's what we have. You can go ahead and check that on your calculator if you want. We're not going to do letter J, but we are going to do letter I. Well, we'll do letter J. Letter I, notice we're dividing by sine squared. I'm going to rewrite this as the integral of 0 pi over 4 of 1 over sine squared theta plus then sine squared over sine squared of theta, which is overwrite it out. So notice I now have the integral. 1 over sine squared is cosecant squared plus 1. Well, do we know the antiderivative of cosecant squared? And of course you do. We look here at the sheet, and let's see here. The antiderivative of cosecant squared is negative cotangent. So I'm going to go ahead and grab negative cotangent. Negative cotangent of theta plus antiderivative of 1 is theta. Evaluate pi over 4. Evaluate at 0. Okay, evaluate at 0. And as you look at this, we're going to look at pi over 4, which is right here. The terminal point is the root of 2 over 2 and root of 2 over 2. Remember, tangent is your y value divided by your x value. So the tangent of pi over 4 is 1. Cotangent is the reciprocal, so that's going to be 1 as well. So we get negative 1 plus pi over 4 minus, now we plug in 0. And the cotangent of 0, well, let's look at that. Look at our coordinate here for 0. Coordinate is 1, 0. So tangent is y divided by x. That would be 0. So cotangent is the reciprocal, so it's undefined. Uh-oh, we got an undefined result. Shoot, why did that happen? Well, if you look at the very beginning, folks, look, 0 right here. The sign of 0 is 0, so it was undefined from the beginning. The fundamental theorem of calculus, part 2, does not apply because it is, in fact, discontinuous in that regard. Okay, last one. Sometimes you need to get rid of something. In this situation, we can get rid of one of these values. We got pi over 3, we got pi over 6. And cotangent, we're going to write that as cosine of theta over sine of theta times sine of theta over 1 d theta. Notice the signs are gone, and that's good news. So we have the integral pi over 3, pi over 6, cosine of theta, d theta. What's the antiderivative of cosine? It's sine. We're going to evaluate that at pi over 3, pi over 6. So what is the sine of pi over 3? Remember, pi over 3 is 60 degrees. And that terminal point there is 1/2 of root of 3 over 2. So the sine value is the root of 3 over 2. And then if you go at 30 degrees, which is pi over 6, notice that those values switch. We have root of 3 over 2, and we have 1/2. Sine is the y value, so 1/2. So in fact, we get root of 3 minus 1 all over 2. So a little bit of review, but definitely some integrals that are a little bit more complicated. Remember, indefinite integrals, make sure that you add the plus c. The definite integrals, make sure you come up with an exact result. That is that, folks. Good luck. I hope to see you soon in class.